Hello, my name is William Gallagher, and I am a staff engineer with the New York State Pollution Prevention Institute. Today, I wanted to talk about a project that was recently completed with the Buffalo Brewing Company with assistance from the Western New York Sustainable Business Roundtable. The goal of the project was to reduce the environmental footprint of the brewery by targeting key metrics like water consumption, energy use, and cleaning chemical utilization, while simultaneously trying to boost production capacity. However, before we move into a full project description, please allow me to provide some background on the participants of this particular project. The Western New York Sustainable Business Roundtable was critical in ensuring the success of this project. WNYSBR is a group focused on improving the environmental footprint of businesses by fostering relationships between them and encouraging knowledge sharing across industry borders where it might not otherwise exist. WNYSBR is made up of 60+ member organizations in a variety of different work sectors ranging from hospital groups to solar companies and everything in between. At the annual WNYSBR Summit, companies come together to build relationships and share lessons learned with respect to pursuing more sustainable business practices without ignoring key criteria like payback periods or feasibility. Thank you to WNYSBR for supporting this project. Moving on to the New York State Pollution Prevention Institute, NYSP2I is a group funded by the New York State Department of Environmental Conservation to assist companies in finding pathways to reduce their environmental impacts. NYSP2I offers multiple different programs relating to the various areas of a business's footprint, including new product validation, supply chain management, and process analysis. Headquartered at the Rochester Institute of Technology, NYSP2I has been helping businesses since 2008 and has assisted a handful of breweries in improving their operations over the past 12 years. For this project, the Direct Assistance Program, which focuses on source reduction of pollutants in a manufacturing process, was utilized. Last but not least, there's the Buffalo Brewing Company, a relatively small brewery located in downtown Buffalo that produces about 500 barrels of beer per year. Buffalo Brewing has been in operation since 2016 and actively seeks to expand and grow the business in sustainable ways, having already implemented a number of initiatives by the time WNYSBR and NYSP2I evaluated the process. Buffalo Brewing was selected to participate in the project due to their willingness to pursue positive environmental changes to their process and because of an upcoming expansion which would add 2,000 barrels of production capacity and double the size of the brew house. So while the project focused on the current facility, it was understood that the opportunities identified and the methodology used as part of the project could be highly beneficial moving into the new brewery as well. While the COVID-19 pandemic delayed the expansion, it is the hope of NYSP2I that the project work performed will help Buffalo Brewing in applying new sustainability initiatives as part of the new brewing process. Typically, NYSP2I projects are broken into a number of specific tasks relating to the work to be performed. In the case of Buffalo Brewing, 4 tasks were decided upon. The first task was related to understanding the water flow throughout the brewery. Water is a critical resource to brewers, and Buffalo Brewing had no knowledge on how their total water usage was broken down between brewing, hospitality, and other water users like canning. As a result, NYSP2I wanted to help Buffalo Brewing gain clarity on how water was being used in the brewery so that reduction opportunities could be more accurately targeted. The second task was related to general improvements that could be made to the brewing process with respect to key metrics like water use, energy consumption, and cleaning chemistry utilization. NYSP2I has assessed a number of different breweries and taken away key lessons from each of them. It was hoped that by combining the knowledge of the breweries, the expertise of a consulting industry expert, and Buffalo Brewing's own process knowledge, areas of improvement might be identified and possibilities for how to decrease the overall impact of the brewery explored. The third task was more specific, focusing on the settling process that Buffalo Brewing uses to remove solids from their Pilsner and lager beers. The current process involves chilling a large tank for up to 10 weeks to allow for solids to settle out of solution via gravity. By reducing these dwell times, not only would Buffalo Brewing be able to increase production, but less energy would be consumed keeping large tanks at low temperatures for long periods of time. Several different separation technologies were evaluated to determine what might help reduce the dwell times and how best to tackle pilot studies moving forward. Lastly, for the options identified, NYSP2I performed a simple economic analysis. For privacy reasons, the economic analysis will not be discussed in detail, though it should be noted that NYSP2I does not typically pursue options that do not appear to be economically viable. The business will not be able to pay back the investment made within a few years. NYSP2I will typically focus efforts on identifying methods of reducing a company's environmental footprint that are more cost-effective. Diving into Task 1, NYSP2I wanted to explore how water was used in Buffalo Brewing's current operation. To help identify the major streams, NYSP2I provided water meters to Buffalo Brewing for installation on the primary feed lines to the brewing process, both hot and cold. These meters were monitored for 1 week, and the information was combined with Buffalo Brewing's operation schedule. In the end, NYSP2I identified that Buffalo Brewing was using approximately 7 gallons of water to produce 1 gallon of beer. This is typical for the industry and represents an average amount of water used to generate 1 gallon of beer. Unfortunately, due to delays associated with the COVID-19 pandemic, mapping the water on a deeper level, namely with respect to identifying which processes consume the most water, was not possible. However, using the meters provided, and potentially installing more, Buffalo Brewing should be able to determine this themselves once operations return to normal by simply dividing the amount of water totalized by the meters from the total water bill for the selected time period. The resulting percentage should represent the water used in the totalized process. From there, it is merely an exercise in making sure all critical processes are metered properly. With some understanding of water flow in the brewery created, NYSP2I moved on to Task 2. To this end, NYSP2I toured the Buffalo Brewing facility in December 2019. Potential areas of improvement were recorded. In addition, as time went on and the project continued, additional improvement opportunities were explored through conversations with Buffalo Brewing's owner. Areas of focus included simple ways to reduce how much water was being used in the brewery, not only by the brewing process, but also by hospitality services, how to reduce electricity consumption related to chilling and lighting, how to reuse and reutilize cleaning chemistries as much as possible before they are discharged to sewer. With respect to water, the most basic option would be to pursue the installation of low-flow fixtures. Hose nozzles, faucets, toilets, and other common water users often consume much more water than one might expect. Low-flow versions of these utilities exist and often cut water use by 30% or more while retaining similar performance. Buffalo Brewing has already implemented spray balls in their brewing tanks that consume less water by design than traditional spray balls might. However, Buffalo Brewing does not have low-flow capabilities for other operations related to the bar, bathroom, or other non-brewing processes. For fully committing to low-flow fixtures, they should be piloted to make sure the performance is still satisfactory. In addition to the low-flow nozzles, it would be possible for Buffalo Brewing to reuse cleaning solution from one process to the next. The final rinse of any wash cycle is relatively clean given the low contaminant levels and small particulate presence in the tank at that point. Conversely, the first rinse is only responsible for removing the largest particulate possible. Therefore, the final rinse of one cleaning process can be used as the first rinse of another with minimal drawback. As a side effect, this would also decrease the amount of cleaning chemistry used by Buffalo Brewing. However, the downside to this option is that it requires a way to transfer cleaning solution from one tank to another, which requires either precise timing of cleanings or additional storage tanks. With respect to energy consumption, only LED lighting was considered to be within reach. Buffalo Brewing is already aware of and implementing the most common energy-saving techniques in brewing, like utilization of a heat exchanger, storage of preheated water for brewing in a hot liquor tank, and insulation of all potential areas of heat loss. Installing LED lighting would help ensure Buffalo Brewing is as efficient as possible with the energy used in the facility given that lighting can represent upwards of 10% of a business's energy bill. LEDs are 25% more efficient than and have double the lifespan of fluorescent lighting, so swapping to them, while potentially taking some time to see the full benefit, pay back their cost, represents a simple way to reduce the electrical operation strains and consumption of the brewery. Well, with respect to cleaning chemistry, while many assume chemicals are only effective for a single cleaning cycle, oftentimes that is not true. Chemistries are often dirty, but the solution itself is still capable of providing some amount of cleaning, despite already being used. Something like a pH meter would be able to assist in determining when a cleaning solution is still usable versus when it is exhausted. While the impacts of reusing cleaning chemistry are relatively small due to the controlled amounts of chemical used by Buffalo Brewing and the size of the brewery, as Buffalo Brewing grows, chemical use and the effect of those chemicals on the wastewater composition will increase. Therefore, implementing control measures now will help to clarify key transitional changes that might otherwise be lost during the transition to a larger brewery. Moving on to task 3, NYSP2I evaluated several different separation technologies in an effort to reduce the dwell times associated with producing beer. Reducing dwell times, as previously mentioned, would decrease the amount of electricity used by the brewery to chill the post-fermentation beer and potentially allow for a 33% increase in production related to additional tanks becoming free. While high-tech separation technologies like centrifugation and microfiltration are typically out of reach for smaller breweries like Buffalo Brewing, given NYSP2I's testing capability and Buffalo Brewing's potential to use the information in the future when the technologies are more feasible, it was determined that benchtop testing could still prove valuable. Therefore, centrifugation and microfiltration tests were performed on the post-fermentation beer with the addition of coarse filtration like cartridge filters to assess a simpler and more accessible technique. Technologies were determined to be successful or not by utilizing particle size analysis. In addition, while some recipe changes were discussed with Buffalo Brewing, none were tested and none will be discussed as part of the presentation for confidentiality reasons. Currently, the main difference between Buffalo Brewing's post-fermentation beer and their final product is a significant decrease in particles greater than 10 microns in size. The particles in the final product skew smaller, while the post-fermentation beer has many particles that reach sizes as great as 50 microns. Therefore, a separation technology capable of targeting these large particulate was desired. For centrifugation, while large particulate was removed, it was done so in a way that generated a significant number of submicron particles. Industry expert Jim Kerr indicated that this may be due to yeast particles shearing and breaking down as a result of the intense gravitational forces. The yeast being destroyed like this would negatively affect the flavor. However, with optimization, centrifugation could be a valid technology if a lower speed separation were performed for a long period of time, gently removing the particles, but still decreasing the overall dwell time of the beer. With respect to microfiltration, a tubular 0.05 micron membrane was used for the separation. The flow rate of clean solution was stable through the test, indicating that the membrane was not fouling. However, as a result of the pore size of the membrane, there were no particles greater than 0.01 microns in size present in the final product of the separation. While this may be seen as a positive, what this likely means is that the flavor of the beer was compromised as too many of the contributing species were prevented from entering the final stage of beer production. With a looser membrane, it may be possible to avoid this issue. However, given that particles greater than 1 micron in size are traditionally best targeted by coarse filtration, microfiltration is likely not the best technology to reduce dwell times. Moving on to coarse filtration, Buffalo Brewing has already tried implementing a filter press and indicated that losses were too great to justify. However, NYSP2I suspected that the losses were so great as a result of the filter clogging from a lack of pre-filtration. NYSP2I passed post-fermentation beer through a series of filters ranging from 50 microns to 1 micron in pore size. Results were inconclusive, but in speaking with industry experts, it was determined that a similar system, if the separation is performed at sufficiently low temperatures, may work for Buffalo Brewing. If Buffalo Brewing is interested in pursuing some kind of separation technology for their post-fermentation beers, coarse filtrations like cartridges, filter paper, or a filter press are likely the best options considering the relatively low cost and ease of implementation as compared to something like centrifugation or microfiltration. Next steps for Buffalo Brewing include the pursuit of pilot studies. All technologies that have the potential to be implemented must be optimized in small batches or tested more thoroughly to determine if full-scale implementation is feasible. Equipment manufacturers are often willing to assist in performing pilot studies by providing engineering expertise in small batch style equipment designed to handle testing on a scale that is greater than benchtop, but less than full capacity. Where possible, contacts who would be able to assist in performing with pilot testing were provided to Buffalo Brewing. However, before making any serious commitments, Buffalo Brewing must determine the value of the production increase associated with decreasing dwell times, without quantifying the benefit and determining a fixed value that would be provided to the business as a result. Buffalo Brewing has no way of knowing which technologies are the right choice. Once the assessment is performed, Buffalo Brewing should have a strong idea on what suggestions to pursue, which to implement as part of the expansion, and which may not be feasible with the current brewing process. That concludes this presentation on the sustainable brewing assessment performed with the Buffalo Brewing Company. If you have any questions, please do not hesitate to reach out to the New York State Pollution Prevention Institute. Thank you for your time. Goodbye.